So this is lesson 64, Algebra 2, complex fractions and complex numbers. And we're going to look at some of these. A complex fraction, if you remember, we did this back in Algebra 1. Complex fraction is when you have more than one fraction line, let's say. So if you had something like 1 over b plus x, and then another fraction line, then you had a over b. So I have three fraction lines here. So if you have more than one, it's called a complex fraction. So that's pretty much all there is to that. And what we're going to do is practice solving some of these, or simplifying them, I guess. So we have in fact, I'm going to make my pen smaller. It just makes it a lot easier. I can write smaller. I'm going to have a plus 1 over 1 over b plus x. Alright, so that is a complex fraction. Alright, I don't care about the a right now. There's no fraction there. I'm going to look at this here. And what I do is you've got a main fraction line right there. And what I'm going to do is I'm going to do work on top and work below before I combine these. Because see, I've got two terms down here that are not grouped together. When I have two terms, I have to make them into one fraction, or one term, before I can mess with this. So, key thing here, one term on top, one term on bottom, before you start combining things. So we're just going to look at the bottom right now. So we've got a plus, and then we're just going to write those down, and then we're going to find a common denominator. Remember that one is 1, so I've got 1 over b plus, I'm going to find a common denominator here. What am I missing? I'm missing a b, so I'm going to have an xb over b. Okay? So now I have a common denominator, and I can write that as a plus 1 over 1 plus, I'm going to put bx instead of xb over b. So now I have one fraction line there, which is good. Now I'm going to take this and invert it and multiply. So a plus 1 times b over 1 plus bx. So I'm going to combine those. So when you multiply those, you're just multiplying by 1. Now I'm going to look and say, okay, now in order to combine these two, I have to have a common denominator. So let's move all this out of the way here, because right now we're at this point in our problem. And I'm going to look and say, alright, what am I missing over here that I have here? Well, this is really a over 1 plus b over 1 plus bx. I am missing a 1 plus bx. So I'll just put it there. Alright, notice I put a 1 there even though I had a 1 here. This 1 is not part of this over here. This whole thing is a group. We cannot separate those and just put a bx over there. Alright, so let's combine my numerators. A times 1 plus bx plus b over 1 plus bx. I'm going to distribute, and that gives me a plus a bx plus b over 1 plus bx. Okay, so that's it for the first example. And here's the second example, 64.2, top of page 272, and we're going to write it as a simple fraction. So again, we're going to look at this, and we're going to ignore everything else at this point. And we're just going to kind of write it. And this is 1 over 1. So I'm going to find a common denominator. I'm missing an x. I've got an x on the bottom here, but I don't have one here. So I'm going to do 1x over 1x. Now I can combine a over x plus, and I'm going to still write everything there the same, x plus b over x. So that took care of that. Now I've got one fraction down there. So at this point, I can take it and invert and multiply. Ax plus 4 times, so I invert it, turn it upside down, and multiply it by the 4 because these are together. And I get a over x plus 4x over x plus b. Now I want to add these two together. Well, I can't because I don't have common denominators. What am I missing over here? I'm missing, again, the group x plus b. So many students will just say, well, I have an x here, all I'm missing is a b. No, you're missing an x plus b. So we put that over there. Okay, now I look over here and say, what am I missing here that I have here? Well, I'm missing an x. Okay, so now I've got a times x plus b for this, plus 4x squared, and then that's going to be over x times x plus b. Alright, and then doesn't really matter if you do this or not, but you can keep going and distribute that a. And get that for an answer. Okay, so not too incredibly crazy hard. Okay, the section 64B, complex numbers. Really the only thing I want you to remember is when you're writing a complex number and they want you to write it in what's called standard form, it's going to be written like this, a plus bi, meaning you might get an answer, you will get answers as you're working with complex numbers that look something like that. Every number in the whole history of the universe can be written like that, a plus bi. Let's say we have the number 37. That is 37 plus 0i. We have no imaginary part. Any number times 0 is 0, so that goes away and is 37. If I have 37i, that can be written as 0 plus 37i. Okay, so this is just the imaginary part. The real number part is 0. So anyway, we'll get into that in more detail later. I'm not really sure why they brought that up in this lesson, but they did, so I want to make sure you know what's going on. The next section says we're going to simplify the square root of negative 2 times the square root of negative 3. Alright, now what you might try to do is say, okay, well, the square root of 6 times the square root of 2 is the square root of 12. Yes, that's true. When you're using negative numbers under the radical sign, the first step is always get rid of the negatives first. So we're going to write this as the square root of 2i times the square root of 3i, because that negative just turns into an I and comes outside. Now I can multiply and get the square root of 6. Multiply these two, I squared. And if you remember, I squared is negative 1. So we get the square root of 6 times negative 1, which is actually negative square root of 6. So that's the answer that I want you to get. So don't fall into the evil trap of multiplying negatives. You can never multiply when you have a negative under the radical. Pull the negative out first and then multiply. And your life will be good because you'll keep getting the right answers. Alright, let's look at 64.4. We have 4i cubed minus 2i to the 4th power plus 2 square root of negative 9 plus square root of negative 3 square root of negative 3. Alright, I'm going to use a couple steps here. First of all, you should have written in your book what I cubed is. And I cubed is actually negative I. And 2i to the 4th is actually a 1. That should be in the front of your book. We're going to pull out the I and be left with the square root of 9. We're going to pull out the I, and we're going to get negative 4i minus 2 plus 2i. I'm going to take some extra steps here. Alright, so, and a lot of this you can do in your head. You probably will skip some of these steps. And that's a negative 1 times 3. So negative 4i minus 2 plus 6i minus 3. And then we combine our like terms. Negative 2 and negative 3 is negative 5. Negative 4 and a positive 6 is a positive 2i. So that needs to be written as negative 5 plus 2i, so it's in the a plus bi format. So that ends up being the answer that I want. Alright, let's look at the next one and multiply. 4 plus 2i, that doesn't look like an I, there we go, times 3 minus 2i. Alright, we're using the FOIL method. So we're going to do our first one first and get 12. Our outside, negative 8i. Our inside, and our last. Okay, so 12 minus 2i minus 4, and I squared becomes a negative 1. So I can combine these two. So I've got 12 plus 4 is 16 minus 2i. And that's in the right format of a plus bi. And I'm done. Alright, let's do one more. And we'll call it good for lesson 64. 5i minus 2 times 4 plus 3i. Alright, what we're going to do here is we're going to do this vertically. Whoops, let's do this, move it over a little bit. 5i minus 2 times 4 plus 3i. Okay, so I'm going to cruise pretty fast here. 6i for multiplying those two. 15i squared. Then I'll multiply these, and I get negative 8. Multiply those, and I get 20i. So I have 20i, I have a negative 8, I have a plus 15i squared, and I have a negative 6i. So this and this give me a 14i, so those are done. I've got a negative 8 plus 15, and that I squared is a negative 1. So I have 14i minus 8 minus 15, which is actually negative 23. So negative 23 plus 14i if I put it in my standard form of a plus bi, which just means the number first, the number with the imaginary number next, and I'm done. So that is problem or lesson number 64.